rate expert with us today from 3 different companies. So we have Samuel Blackade from Ginkgo Solar, we have Bifacial from Sterling and Wilson, and we have Jose Torres Brito from Soltec, and myself, as I said, Carlos Rodriguez from ATA Renewables. So it's time to know our audience a little bit better. So we are going to proceed with a poll. So Belen, can you put the poll on? It's going to be just a very simple question. The question is very simple, and there it is. Are you seriously considering using bifacial technology in your next PV projects? And the answer are yes, no, not sure. So please, let's proceed to vote and let us know what do you think about the subject today, and let us know you a little bit better. So the question is, are you seriously considering using bifacial technology in your next PV project? Yes, no, not sure. I will give you a few more seconds. So 5, 4, 3, 2, 1. The time is over. So let's see the results. Here it is. So, well, a little bit polarized. So the results are 47% yes. So you are considering to use bifacial technology in your next PV project, 10% no, and 43% not sure. So we hope that this webinar will help you to solve all the doubts and all the questions that you have concerning this technology. So I'll briefly introduce the subject, and then I'll give the floor to our panelists, whom will go deeply into the subject, also from different angles, as they have different track record. And as I said, at the end of the session, we will be answering your questions during the Q&A. So I'm going to share with you a little presentation, if I can't. Let's see. I don't know why it's not working. Now, sometimes this happens. Great. So the webinar today focuses on bifacial models. Bifacial models are basically photovoltaic models that are able to utilize light from both sides, increasing therefore the yield of the PV project. It's not a new technology. It was first described in 1960, and the first laboratory cell dates back from 1977. It's indeed a variation of the photovoltaic technology, which, as we know, already has a great track record. The commercial interest in the bifacial technology is now growing as technology costs are going down and the industry looks for new ways of improvement. This webinar is not only about bifacial models, but also designing PV projects with this technology. So there are certainly several factors that you will have to rethink when designing bifacial photovoltaic projects, such as the pitch, the tracker height, the ground cover radio, as those factors are affecting the yield gain of the project. And the idea is always looking to optimize the base case. So, for example, the height of the tracker is as tall as possible, could be better for the bifacial gain, but you will be having a higher cost for your tracker. So you have to always look for the optimal point. I'm sure our panelists will explain this factor in greater detail. There are also other factors like knowing the albedo of the project location that is now critical, as well as other weather parameters such as humidity, And it's also very important to start collecting data from the ongoing projects to better understand the whole commercial potential of this technology. Here is where advisory services may be required, helping to achieve the proper design and the proper construction of bifacial project, as well as validating the results that are being collected in the ongoing projects. From ATA, we are already participating in several projects, and we look forward to increase our experience in concerning this technology. So after this brief presentation of the subject, I will now give the floor to our first panelist. That could be Baiba. So I will be sharing the screen. So Baiba, your turn. You can present yourself and go from there.
Yeah, hello everyone. Thanks for joining in from different corners of the world. My name is Vaibhav Joshi, and I'm heading the business development for Sterling and Wilson for Asia and Australia market. Sterling and Wilson, it's today one of the largest global solar EPCs, and if we take the record outside US and China, we are the #1 EPC in the world. We have been working with whatever all new technologies that come across the world, be it bifacial, be it floating solars, be it storage and all. So yeah, we have done our own analysis, and we also do our own understanding when it comes to bifacial. So my presentation will typically be giving you a brief about what bifacial is and what are the main factors that bifacial works on, followed by what are the basic parameters to be looked into in terms of, so introduction to bifacial, what is albedo, the basic ingredient of the bifacial, then the yield parameters which are to be looked into in bifacial, cost parameters, advantages, and then maybe some issues. I won't say disadvantages, they are more of the issues which need to be tackled going forward. And lastly, what's the future, how we are progressing in terms of bifacial. So to start with, I would like to give a brief introduction on bifacial. So I think we all know bifacial means capturing the light from the front as well as the back of the module. So the front side typically is like a standard module, which we know. The only difference here is the back side of the module also gets reflection from the ground, which is a diffuse reflection, and that reflection, if captured properly, gives you more energy. So that's the basic understanding. And basically the bifacial is all dependent on the albedo, how the albedo of a particular site is defined. So what's albedo? Albedo is basically a ratio of the reflected radiation that comes back from the ground divided by the actual radiation on the site, and this albedo differs based on the type of the soil or type of the ground which we are having. So if you see, I mean, the more clear the site is, when we say clear, we move towards, let's say, the snow and mirror. So as clear the site is in terms of the properties, you will get the best albedo, and this albedo is captured by a proper technology, in terms of how we put the installations with the trackers, with the modules, with the inverters, that how best we can capture this albedo, that defines our gain. And I think many of you would have heard about a device called Albedo Meters. So just to brief you, an albedo meter is nothing but simply two pyranometers put together, one facing up, one facing down. So this albedo meters actually captures the albedo of the site, and basis the albedo of the site, we are able to define what is the gain, or what is the gain on this particular site versus a normal one. So that's pretty much what defines the bifacial. Now, what are the parameters that give you a better yield in bifacial? So as I clearly said, one is the ground albedo, the reflectivity of the ground, how well it reflects the radiations from the ground towards the rear side of the module. Another important factor based on the geographical location is the clearness index. So clearness index is basically, the amount of extraterrestrial irradiance which transmits through the atmosphere and reaches to the ground. So having said that, for example, if we have a diffused atmosphere, we could see a better albedo. So, the worse the clearness index is, the better is the albedo, though it is not good for the overall site, because if the clearness index is bad, you are not getting the proper irradiation from the front. But if you want to say where do I get more on bifacial, is more in the diffused atmosphere. So the more diffused the atmosphere is, the better is the gain in the bifacial. So that's about the geographical location at point. Now on the technology, now today everyone is working on making their module best in terms of giving the output. And I think my friend from Jinko will cover more about the module part of it. So yeah, it depends on the bifaciality factor of the module. And secondly, today we are seeing that, the bifacial modules are giving us a lower annual degradation rate to the tune of 0.3 to 0.5% per year. And thereby we are able to get a 30% product life. So that means if with this, our project is there to be for 30 odd years, and hence obviously it helps in the financial modeling, it helps in a better generation throughout the project life cycle. Now coming on the EPC part, on the system configuration, what are the basic parameters that we have to look into when we are designing a system? So elevation is, it's the basic aspect here is, the more you lift the module above the ground, the better is the bifaciality the better is the result which you see. But here we need to see, there is a trade-off between lifting the module above the ground versus incurring more cost of the structure, tracker, and the installation. So there has to be let's say a limit which defines a trade-off between the elevation versus the gain. And there will be certainly a limit above which you won't get the same generation gain with increase in elevation. So that's pretty much which needs to be seen, which we as an EPC company have to look into by doing multiple round of iterations and finally deriving the correct elevation. In terms of azimuth, so for example, if we are putting something just on the ground and then lifting it and to a certain height, then for example, we have seen traditionally that up to a certain latitude we have seen that maybe an east-west kind of configuration will give a better yield compared to a north-south. So that's pretty much important to see that, what azimuth we are going into. Tilt is obviously the better tilt, the better we get a generation. But now coming to the fourth point, which is very important, and this is something which we need to see, is the height-width ratio. Now, when we talk about width, it's about, let's say, the ground coverage of the modules. So we are putting on 2-row or 3-row height tracker. Now this ratio of width versus height, this is something which is very important to get the generation gain out of the bifacials. Historically, the simulations and the kind of projects which we are working on, we have seen that, the height versus width ratio should be not more than, should be not more than a certain level, because obviously again it will lead to the same factor that, if you are putting a 2-row, 3-row modules, then obviously the percentage gain in all the 3 rows will not be similar, and the more rows you start putting in, the gain starts diminishing. So that's pretty important to see. And then finally, the Dchd ratio. So there is a limit. We can't go up to any extent on the DC ratio, otherwise we'll face more clipping losses, and then the entire agenda of putting bifacials for getting a better yield will go away. So these are the pretty much the yield parameters which needs to be seen when we are designing on bifacials, or we are and with the same coming to the cost parameters, obviously module cost. So that's the most important point, that at what cost the bifacial modules come come for the project. I mean, that's pretty important. In BOS cost, you might see increase in tracker cost because you are elevating, and obviously the steel is going up. Your cables go up to certain extent, and then also the combiner box, because you are taking inputs from the front side as well as the back side. And then you have some addition of the clamping cost. So these are the parameters which increase the BOS. In terms of installation, you might see an increase in the foundation length and the cable trenching cost because the cables have gone up. Land cost, from the developer's perspective, it is very important to see that, what are the optimum distance we are keeping for row to row distance, and how best ground coverage ratio we can cover. O&M cost, now this is interesting. Why I will say that is because maybe your cleaning of modules reduces with bifacials, but maintaining the ground conditions is a very important aspect that we need to see. So for example, today we are putting bifacial on a ground which is prone to develop grass. So going forward, you have to clean this ground at regular intervals to maintain that bifaciality. So this is pretty important in terms of, at upfront it might not look to be a higher O&M cost, but going forward it may turn up to be a higher O&M cost just to maintain the albedo of the ground. So that's something which is pretty important to see. Financing wise, now we see the market is pretty mature, and bifacial is accepted as a technology. So financing, maybe if we talk 1 year before, would have been a problem, but now we are seeing the market maturing and the financing is not becoming a big problem. Land preparation, again, if we increase the total area because of putting the bifacials, then obviously your land preparations cost go up. Project development will more or less remain the same. So these are the basic parameters in terms of cost that needs to be seen. Now coming to the advantages, yep, it's a higher efficiency. So obviously that's a big advantage. Extended durability, because we are putting glass composite. So, the environmental and mechanical influences are less. More flexibility in PV design. So the idea of putting this point is with bifacial, maybe the orientation, the tilt, the angle might not be that important, because any which ways you are going to capture the radiation from some direction. Extended warranty, obviously bifacial panels are coming with 30 years warranty now. So that's again lower degradation, which I already mentioned. The bifacial modules are PID free. And then if these are frameless panels, you're not putting any aluminum frames, so no grounding required. So that might be an advantage. Coming to the issues, I will say more than disadvantages. The modules may be heavy because of double glass rather than a single glass. Another point is at what rating to sell these modules. I mean, obviously, we all know PV modules will be sold in watt peak basis. So how to determine a watt peak of a module when it is being sold? On albedo, as I already mentioned, it depends on the properties of the surface, color, thickness, and all these factors can change. For example, today I measure an albedo at a site for 3 months when it was typical summer. Now, if this site is also prone to rains for next 3-4 months, maybe that was not getting captured, because during that point, the albedo might be different. Secondly, if it is a vegetation, then regular cleaning is required. And then even the soil with its age, for example, today a soil is giving an albedo X, but 30 years down the line, because of the soil properties itself, the albedo would reduce. So that is a particular thing which is very important to address or to consider. And then debate between framed bifacial or unframed bifacial, because with framed, your BOS cost might get a bit high. But unframed modules, they cause less backshading, but their BOS cost might go high. So that's a trade-off again. And then finally, the mismatch between the front and rear surface, that is something to be seen, how to capture it properly, because the front side irradiance versus back side. Similarly, the temperature on both the sides, current on both the sides, and soiling losses on both the sides. So they are different. So how to capture this mismatch? That's something very important to be seen. Going forward, I mean, yes, the one of the best ways to work on bifacial is put a vertical installation. So nothing to do with, you know, because both the sides will capture whatever best is possible. That is something which will gain traction going forward. And secondly, the double peak profile, which is the east-west kind of profile. So what happens is it helps you in the generation peak. So let's say your 50% panels face east, 50% panels are facing more to the west, and then, you know, your morning generation and the afternoon generation both are getting captured, both are being well managed. And then going forward, we'll see more bifacial coming on the floating technology, because water as a reflection will be much better. You won't have to manage the properties of water. As I said, you know, for grass and other, you have to manage the properties, but here there won't be any problem of managing the properties of the ground. So these are some of the trends which will gain more traction, which will be more live going forward, as I would say. So yeah, and that's pretty much from my side on the presentation side, and we'll be more than happy to address any queries going as they come. Thank you. Thanks, guys.
So thank you, Baiba, for this awesome presentation. I think there are a lot of questions in the Q&A box, so you can start answering if you want. Anyway, we will be answering at the end of the session as many questions as possible. We are breaking record here. We are a lot of people in the webinar now. There are people from Washington, from California, from IT, from South Africa. So we are global now. And let's proceed with the next panelist. Hi, Samuel, are you ready? Just, you have you are unmuted. We cannot hear you.
Yes.
Right now.
Yeah,
right.
We're all good now.
So thank you, Samuel.
Thank you. Just let me share my screen 1 second. Am I full screen now? Good afternoon, everyone. My name's Samuel Blackadder. I'm from Jinko Solar. I'm the head of utility and projects for Australia. And I wanted to talk today about our bifacial product, mainly the PERC and the mono products for bifacial. The presentation will be a little bit more brief, but coming up and answering a lot of the questions that we get typically from EPCs and also developers regarding modules, designing, and about Albedo. And as I've said before, is that it is a maturing market now. Next year, we'll be looking at producing around about 1.4 to 1.6 gigawatts of production of bifacial within Jinko. So it is a very exciting time for this project, or for this product, sorry. So we'll start the presentation. So we'll be going through the module structure, which has been talked briefly about. I won't go too far into the bill of materials and some other products, but if anyone is after that, we can discuss more online or in the Q&A. We'll be going through the warranty, the degradation, and how that plays into account with LCOE. I believe there's a few questions on that as well. And how do we calculate the extra energy yield in terms of how do we put that into PV Syst? How does that get modeled? And what are the figures that you can use in those calculations? So we do have two different types of bifacials within Jinko. We do have the dual glass design, which is frameless, and we also do have a 40mm frame design as well. What we've noticed within the Australian market, and it's mainly due to wind load regions as well, is that we need to have a frame design. This is mainly due to high wind load C and D regions that require this extra protection, but we can accommodate either solution for the customer. Regarding the warranty, it was posed in Q&A a little bit before. The bifacial modules will have the similar degradation to a dual glass module. This is because we are using similar products and we are using the glass on both sides. So for that, we can use the calculations for LCOE and for your yield on a 30-year calculation period. For the first year there, you do have 2% degradation, which is combined, and each year after that, from the 2nd to the 30th year, is 0.5% degradation. This is a step down from the 0.7%, which is on the standard modules. So we do have increased savings there, or sorry, increased generation that we can guarantee to the developer and the EPC. So as we can see through that graph, we are going to approximately get just over 20% extra for the 30-year lifespan of the modules. So regarding albedo, I won't go into this too much because Vabhav's presentation was far more in depth than this. But with albedo, it's about the light reflection from the ground and the substrate surfaces that you're going to be using within the project. All these surfaces will need to be maintained throughout the period, otherwise you'll find that generation can be affected. We do suggest that the ground clearance will be somewhere between 1 to 1.2 meters for elevation to get the appropriate amount of albedo and the light reflecting back to the backside of the panel. So for some of the different surfaces that we're going to be talking about, these are the most common ones that we get requested on. These are some energy gains that we've actually calculated from our R&D facility in Shangrao. Shangrao is one of the facilities that will be producing the bifacial. So for us, we've been conducting some long-term tests and finding the actual differences with the modules as well as Albedo Meters to find out what the actual reflectance and the gain of yield is. It's actually interesting to note we do have a wide range that go well beyond these 5 categories. We also look at things like copper plating, fresh snow, wet snow. We've got differences in wet bitumen and dry bitumen, and also with galvanized steel and the difference if it's dirty or it's new. So the most important thing that EPCs and developers will need to do is to assess what that surface is, how it can be maintained, and what yields you're going to be able to get. As Vabhav has pointed out as well, in areas that will have monsoonal, I suppose, seasons and also change of seasons, this will potentially affect the reflectivity of the surface as well. So these are all things that we're going to have to take into account. We try to help guide our industry partners in giving them the information, but we do have to do comprehensive site analysis to ensure that the figures that you're putting into PVsyst or the other systems that you may use will be calculated correctly. So here, this is one part that does confuse some people, or there's not some understanding of it, is that people think that if there is a reflectivity of, if we're using grass and it's approximately 20%, you don't get an actual 20% gain from the module. That's the actual light reflection from there. What we've done is we've got some expected yield gains to give you a bit of an idea about how that actually plays out. So as you can see there, for a lot of projects, even if we look at, say, desert sand, although it is highly reflective, the expected yield gain from that is approximately 10 to 15%. I have seen some EPCs putting towards to developers in putting those calculations as having the albedo as the expected yield gain. The biggest problem with that is that as an EPC, if you set out those incorrect expectations to a developer, it's obviously going to give some incorrect yield gains and will cause some issues. These have been calculated and we've received from TÜV Rheinland, as you can see from 2018. We do have a more comprehensive list, but if you contact TÜV Rheinland, they'll be able to help you to come up with these reports as well. A little bit in terms of the installation, and I'm sure Jose Torres from Soltec will go into this a lot more in depth, but it is important to make sure that you make the right partnerships with your installation and your racking company. Racking is going to be a quite a significant part as modules, in that you need to make sure that you choose the right manufacturer that can help guide you on this, because you do have a number of factors that will affect the module in terms of the generation. So a couple of these are the bifaciality factor, the ground clearance, and also the reflectiveness. So ensuring that you not only engage your module manufacturer, but you also engage your racking manufacturer to talk together and make sure that we're all on the same page, and that we work together to make sure that your project will be successful. Oh, what's happened here? So this is regarding the PV Syst simulation. So I just want to touch on quickly for some of those people that are in this forum and are looking at PV Syst, and actually where do they put some of this information. So as you can see here, you've got where you can select the PV module within PV Syst. If you look up the top corner that is highlighted, that's where you can select your bifacial system. From within there, you then need to put in your ground clearance and your ground albedo. So underneath there, we've got some different options which we'll be able to show how it calculates in terms of LCOE and IRR later. But you've got there some options with your traditional mono-PERC and also your bifacial options with some different ground clearance and the reflection percentages depending on the ground type. So there you can put in your ground albedo and your height above the ground. Oops, I think it's missed a part of the slide, sorry. But I'll be able to update you on that later. So those are the parts you put in there to help putting your figures into PV Syst. The system cost breakdown is quite more in depth when you're looking at the bifacial. And I know Veb has gone through that, so I won't go into it in too much detail. But there is a lot of other parts of this installation that you need to look at and to ensure that you've actually covered off. And one of the most important ones is actually maintaining that surface structure and making sure that it has the right reflectivity in your O&M. Coming down to the extra energy yield, what we've got is we've got some project costs per dollar. These are in, well, it's in American dollars. So this is for a traditional mono-PERC. And then you've got the suggested extra cost from going from a mono-PERC to a bifacial mono-PERC. The extra cost there we've got is approximately about 1.5 cents to go to that framed option. On to the next slide. We'll see that we've got a breakdown roughly of how that LCOE roughly compares against to the IRR. And as you can see, with the US cents per kilowatt hour, having that subsurface, we really need to make sure that the extra costs for your BOS and installation is actually going to be worthwhile. And we can actually see that depending on your surface and your extra costs involved, you can actually have a greatly increased IRR. And this is one reason why that a lot of companies are looking at picking this up. These figures are based on a traditional 25-year degradation and warranty period, only because I wanted to compare apples to apples and to ensure that we weren't showing a 25-year period versus a 30-year period. Obviously, if you were to compare that traditional mono-PERC to a bifacial mono-PERC with a 30-year period, then those figures would greatly increase on your IRR. And that's all that I have.
So thank you, Samuel. And we have a lot of questions also concerning your presentation. I can see a lot of questions concerning Albedo, so we'll be answering that. Viva has already answered a few of them. So also a lot of questions concerning trackers. So Jose, your turn. And thank you very much, Samuel. And you can start, Jose, when you're ready.
Can you see my screen?
Yes. We can see it, not full screen. Now, all right.
Okay, great. Thanks for that again. So let me introduce myself. I'm Jose Torres, sales engineer based in Melbourne. I've been in the industry for about 10 years, both on the panels and the racking side of things. So this is very much of interest for me personally and professionally. So a little bit about Soltec. We're a tracker manufacturer, and we've been doing bifacial designs for a few years now. The first project that we did was in 2015. It was a commercial size project, first in the world, and we've been tracking that as it comes along to see how that's impacted the difference in yield. And on the back of that, we've we launched BiTech, which is Bifacial Tracker Evaluation Center in 2018. This is so we can understand how bifacials impacts the yield and how we can maximize from a tracker perspective the yield that we get using bifacials. Just a little bit more about that. We've done a 17 megawatt project in Israel in 2018 as well, and as the other panelists have pointed out, that there's a lot more traction and a lot more interest in bifacials. So much so that we're looking at doing over 1.1 gigawatts worth of bifacials in 2019 that has been contracted already. I won't go into this too much. As the panelists have said, as Samuel said, the panel's bifaciality is essentially just trying to maximize the re-irradiation on the panel. So as a tracker, that's sort of the perspective that we're looking at. How can we maximize that re-irradiation? From a bifaciality ratio perspective, there's certain different places where you can get the radiation. One of them is the panels, diffuse energy is another one, but the biggest one is the soil. And that has a lot to do with albedo, which is something that you have to really think about when you're looking at bifacial projects. Again, I won't go into too much, but albedo is essentially the how much reflectiveness a surface has. So obviously, the wider the surface and the smoother it is, the more gain or the more energy or the more reflection there is that you can capture. We've got snow there, 90%, dry grass at 33%, and spring at 25%, green grass. As the other panelists have mentioned, it is a big impact on the energy yield you can get from it. What we've noticed in our projects and in BiTech is that it's approximately linear. So the higher the albedo, the more bifacial ratio or the more radiation you can capture. Also pitch, as it's been mentioned, is very crucial as well. Pitch is the distance between trackers east to west. Being a dual panel, two panel portrait tracker, it is very advantageous in that sense. The wider the aisles are, or the wider the distance between the trackers, that means there's more surface area of the soil, which means there's more reflectiveness, which means you can have, there's more potential of energy gain on the rear side of the panel. Obviously, as BJ mentioned, that the wider it is, you start to lose land usage. So that there is a sweet spot there. We recommend 12 meters, but anything between 10 and 12 meters is ideal in the instances that we've seen. So to sum up, albedo and GCR have a big influence, especially in bifacial panels. You can see that the influence that they have is greatly impacted as you go higher in albedo, and as once you get the right GCR, you can have a bigger radiation. You can have a higher capture of radiation on the rear of the panel, more so than on the front of the panel. One of the other factors, as mentioned previously, is the height of the tracker. The height is very crucial in terms of causing shading. So the higher you get, the less shading you cause. But again, there is a trade-off. You can go too high, which means that there's more material cost, which means that the tracker becomes a higher cost, so you start to lose the benefits of having bifacial panels. In the studies that we've done, 2.35 meters is a sweet spot again, not only for installation purposes, but for cost of material as well. I think this is a crucial part of when choosing the racking is the type of tracker or the type of racking and the shading that it causes on the back of it. Obviously, there's always going to be shading, but the less you can do that, the more yield you can get. Having two-panel portrait, you have the torque tube running down the middle, so there is no shading on the panel directly from the torque tube. Being able to design it with a little bit of a gap in the middle as well means that there's more light getting through, which causes less shading. Again, less piles, the less objects you have on the underside of the tracker, the more chances you have of capturing that radiation. And this is very important because of hotspots. Bifacial panels run with a high current, so they have potential of hotspots. Having a torque tube running down the middle of a panel can have big issues on hotspots. So I think that is something that has to be considered when designing it or when thinking about bifacials on a project. This is our project that we did in Chile in 2015. It was these figures are provided by NL Green Power. Excuse me, and it shows that it has been an average increase of 13% energy gain, and that's been provided by a third party. With the energy gain, you obviously lower your LCOE and you increase your return of investment, and there's a big impact in that just by using bifacials, which leads me to the next point. There's two ways of looking at it when you're designing a bifacial plant. You can either hit the same peak power on it, so you 50 megawatts, in this instance 50 megawatts, or you can look at hitting the same kilowatt hour per year. As you can see, there's obviously higher cost for the module price and for the DCAC side of things, but you're still getting an energy gain of kilowatt per hour kilowatt hour per year gain of 14%, which has an advantage. Or you can go and try and hit the kilowatt hours per year, which means that your cost overall will be lower. Excuse me, because of less modules, less trackers, less installation costs. It means that the final cost will be 7%. So that's an interesting way to look at when you're looking at bifacials in a project. So just to sum up what I've said, high albedo, or the wider and smoother the surface, the higher the pitch, or the bigger the pitch, and the higher the height, with the sweet spot on there and the less shading on the back, you're going to get more energy, which is always good for a project in terms of return on investment. So I guess that's what it's from the tracker perspective, and that's my presentation. Thank you.
Thank you, Jose. Thank you very much for your presentation. I hope a lot of doubts have been solved. So let's proceed with the Q&A. I would like to start with, well, it seems like albedo is one of the main concerns. So let's start with one question here. It appears that albedo is the key determinant factor for these panels. For this project that had received financing, how the albedo was measured or calculated? For instance, do independent technical advisors provide a kind of albedo report? If that case, what is the period across which albedo is being measured? Thanks. So thank you. From ATA side, from the advisory side, I can say that yes, we can provide that services. We can't deliver a team of experts in the location of the project, and we will proceed with the data measurements. The period depends on the available time, but let's say Bypass presently said that at least a period of 3 months will be needed, at least. And at the end, we will be providing a certification report, not only for albedo or other weather parameters such as humidity, but also for the yield data recorded and so on. I don't know if our panelists want to add something, maybe for the project financing perspective. Maybe Vaiva.
Yeah, I think Carlos, you're right in saying that it has to be measured for a longer period, and yes, there are technical advisors like ATA which can do this. Coming to the financing part, yes, I mean as I mentioned in my presentation, you have to maintain the albedo. So when the financial modeling is being done, you have to consider a cost for maintaining the particular site. I remember for one of the projects in Egypt, someone was one of the requirements was to put a marble flooring at the solar site. So I mean just that, so that the site remains constant throughout the 20-25 years of period. So see, mostly in desert, for example, I would say in desert areas like Middle East, it's a no-brainer. It will always remain that kind of profile only. The main, and for example, a snow area, like let's say the top areas of, let's say, Europe, still the profile will remain the same. The difficult profile is a soil property which is prone to develop grass. So that is the main kind of profile which we need to capture well. So that's why you will see, and I have always seen most of the technological innovations happen mostly in the Middle East market, and it becomes the most competitive market also for that sense, because there it's defined, it's a desert and the properties will remain the same. Snow areas, properties will remain the same. So mostly it's to do with the grass areas, for example. And yes, as I said, you have to inbuilt a cost in your model, that what will be your cleaning costs and what will be your cost for maintaining such kind of site. But yeah, I mean, today, as I said, finance institutions understand this, and if you present the data properly, they are more than happy.
Right. Thank you, Vaiva. I can see another question, this time for Jose, that said, for trackers, is the negative impact of the tongue being in case of one portrait configuration measured, hotspot issue verified? I don't know if you can see this question, Jose. It's the last one in the Q&A.
No, I haven't seen that. Sorry, it's about the torque tube hotspots.
Yeah, how the tongue being in case of one portrait configuration measured, hotspot issued verified. I think it's, yeah.
In Bitech, we've done the comparison with 2 different types of trackers. And I don't know if I probably went too quick, but there was an image there which was taken straight from our test site, and you can see the difference between hotspots on a 2-panel portrait compared to a single panel portrait tracker, and that was the hotspots.
Okay, thank you. I have another question concerning the cost. How higher is the maintenance cost as compared to bifacial? Any estimate percentage? Samuel, yeah, I think you want to answer.
Unfortunately, no. I don't really have anything from my side, because O&M is something that we're not really involved in, but there would be a cleaning aspect not only on the top side of the modules, but also on the underneath of the modules. especially if you're looking at some areas that will have, I suppose, different mediums that may be attached to the bottom or can stick to the bottom of the module. So in salty or humid conditions, and then sand. So there may be something to look at.
Great, thank you. I have another question concerning the case study in Chile that I think is also for Jose, if I'm not wrong. What did the energy gained compare it to actual energy generation from monofacial installed at the project? So what did the energy gained compare it to?
Yes. That was compared to, again, monofacials against bifacials. The same site had a test part where it was compared, so you could see the difference between. It wasn't just a commercial project; it was also a test site in terms of seeing what the difference would be. So there was one part of it that was monofacial compared to bifacial.
Okay. So you can see another question here. Let's see, some that is interesting enough. Someone is asking Samuel, do you provide FR for rear face? Yeah, FR, I don't know what they mean, but FR.
Yeah, if they can get the,
okay.
If you can ask what the FR is.
So the question is Jose Arribas. Jose, could you say to us what do you mean with FR? If not, in the meantime, I will proceed with another question.
Yes, so your flash reports.
Flash report, okay.
Yes. We do supply the flash reports for those models, yes.
Okay, great. So I think we have enough time for another two questions. Another one concerning simulation. So what simulation packages are the panel member using to model bifacial effects? I'll say PVCs, but I don't know if you guys have another software.
No, it's the same software. We are working on PV systems right now.
Okay, and I can imagine the Jose also for you is the same.
Yes,
Okay.
it's on my side as well.
Okay. So we have another question. Stan, what would be the average good field type of frequency to maintain the ground, so the grass, etc., with the designed albedo levels? So once you have designed your project for a particular albedo characterization, how to maintain this albedo level?
I would say for Australia specific, you can have a cleaning cycle of, let's say, 3 months, maybe 4 times in a year, that you have to clean it to maintain it to the same level as it was before.
Okay. Let's proceed with the last one. So we have to check it right. What are the challenges concerning the installation compared to one-faced modules? For instance, are tracker well tested for bifacials? I think this is one for Jose. And
Sorry, could you ask that again? I was answering a question.
don't worry, Jose, that's right. So they are asking is what are the challenges of installation compared to one-faced modules? And so they ask is if tracker are well tested for bifacial models.
Well, one of the advantages of Soltec is that there's not much of a change in terms of installation. The installation is pretty much the same. The only difference is the panel attachment or the panel clamps, which it doesn't create much of an issue. So yeah, essentially it's pretty much the same with Soltec.
Okay, so we I think we have running out of time. So thank you very much to all of our panelists. Thank you, Samuel. Thank you, Raiva, and thank you, Jose. And thank you to all of our audience here for your time and also for your all your interesting questions. We have tried to answer as many as possible, and just remind you guys that we will be sending you the presentation that have been completely recorded. So thank you very much, everybody. It's time to say goodbye.